Right now, the air around you is about 420 parts per million carbon dioxide. That is the highest it has been in the entire existence of your species. It has climbed by more than 130 parts per million in a century and a half, and every climate scientist alive is watching that number move. It feels fast. It is fast. Now hold it in your head, because today you are going somewhere the number is 5 times higher. Not 5 times higher and steady. 5 times higher and still climbing in the middle of the fastest natural carbon release the planet had seen in tens of millions of years. There is no ice anywhere on Earth. There are crocodiles near the poles, and the whole world is running a fever it did not choose. Welcome to the Paleocene. Eocene Thermal Maximum set the dial to 56 million years ago. That is close, in deep time. The dinosaurs are already 10 million years gone. The continents are almost arranged into shapes you would recognize. If you flew over this Earth, you would half know it. But the atmosphere is a different machine. Carbon dioxide had already drifted to somewhere around 1,000 parts per million, a warm, ice-free greenhouse world as a starting point. And then, in a geological instant, something injected a colossal pulse of carbon on top of that. The leading suspect is volcanism. As the North Atlantic tore open, sheets of magma pushed up into ancient carbon-rich sediments and effectively cooked them, belching carbon dioxide and methane in pulses over less than 20,000 years. That is a blink in deep time. It was enough to raise global CO₂ by something like 70%. You are arriving at the peak of the spike. You step out into what will one day be Wyoming. It does not look like Wyoming. It looks like a bayou that swallowed a jungle. Dense subtropical forest, broad wet leaves, standing water, the drip of humidity off every surface. The air is thick and green smelling and warm in a way that presses on you. You are wet within minutes, not from rain, from yourself. The humidity is so high that your sweat has nowhere to go. It sits on your skin. This is the detail that matters more than anything else today, and you will understand why later. But here, at this latitude, it reads as Earth. Uncomfortable, oppressive Earth, but Earth? Birdsong? Insects, a forest doing what forests do. Could you survive an afternoon here? Probably. Could you survive at the equator? That is a very different question. Start with your lungs because they are fine. At 2,000 to 3,000 parts per million, carbon dioxide is high, far above anything you have ever breathed. But it is not the wall it was in the deep Cambrian episodes. This is roughly the CO₂ level of a stuffy, crowded meeting room with the windows shut. You would feel it over hours, a dull headache, a creeping sluggishness. Your blood chemistry shifts slightly as your body works a little harder to dump the carbon dioxide it makes. What you would not get is the fast, frightening cognitive fog of truly extreme CO₂, the kind that drops you where you stand. Your thinking stays mostly clear. You can hold a conversation, you can make a plan. Over a long enough stretch you would tire more easily, and your judgment would dull at the edges, but none of that arrives in the first hour. So the air itself does not kill you. That is the trap of this place. It invites you to relax. And relaxing here, in the wrong latitude, is exactly how it would kill you. Not through your lungs, but through your skin. Here is the one number that decides everything today. It is called the wet bulb temperature. Your body has exactly one way to cool itself when the air is hotter than you are. Evaporate sweat. Evaporation carries heat off your skin. It is the entire system. But evaporation only works if the air is dry enough to accept the water. When the air is already saturated, hot, and utterly humid, your sweat stops evaporating. It just runs off. And your internal furnace has nowhere to send its heat. Climate scientists Stephen Sherwood and Matthew Huber put a hard number on this in 2010. A sustained wet bulb temperature of about 35 degrees Celsius is the physiological ceiling for a human being. At that point, your core temperature climbs no matter what you do. In the shade, still, naked, drinking water, it does not matter. A healthy person overheats fatally in a matter of hours. Today, almost nowhere on Earth reaches it. At the PETM peak, model reconstructions suggest the tropics may have brushed right up against that limit. Here in Wyoming, at latitude, you are hot and miserable and drenched, but below the line. You can shed heat, just barely. Move to the equator and the arithmetic inverts. The air is saturated, the temperature is murderous, and your sweat becomes useless decoration. You would not feel a dramatic threshold. You would feel tired, then confused, then you would stop. That is what makes it so dangerous. Would you even know you had crossed the line? Now look down, because the forest floor is full of beginnings. A small animal picks through the leaf litter, about the size of a large house cat or a small dog. It is a horse. One of the very first, the ancestor of everything with hooves and a mane. Paleontologist Ross Secord and colleagues traced these earliest horses through the rocks of Wyoming's Bighorn Basin and found something remarkable. As the PETM heat peaked, they shrank, dwarfing by roughly a third, and then grew back as the planet cooled. The fossils record the fever in the bodies of the animals living through it. Up in the branches, something else new, among the earliest true primates, small and wide-eyed. Your own family tree has a twig here. Nearby, the early relatives of elephants, the ancestors of hoofed grazers. Philip Gindrick spent decades reading these Bighorn Basin sediments, and they show the same story from the ground up. This warm pulse is when the modern orders of mammals arrive and fan out across the continents. Familiar family trees. Alien forms. Life is not being destroyed up here. It is diversifying fast in the heat. So, could you stand here? In Wyoming for a day? Probably yes. The air is breathable. Your head aches from the carbon dioxide, and you are soaked to the skin, but you can still cool yourself, think, and function. Stay hydrated, stay in shade, and you would walk back to the pod. Survivable with latitude. Take that same body to the equatorial tropics of this same world, and the verdict flips completely. There the wet bulb temperature may sit at or near the human limit. Your sweat stops working. Your core temperature climbs. Not over days, over hours. There is no acclimatizing to it, no toughing it out, no shade deep enough. Heat stress would take you before thirst or hunger ever got the chance. That is the strange, sharp lesson of the PETM. It is the first place in this series where your survival depends not on the chemistry of the air, but on a single line of latitude drawn across a too warm world. The same body, the same day, the same planet. Safe here, dead a few thousand kilometers south. The air never changes its mind about you. The geography does. Look at the ocean. On your way out, because that is where the bill came due. The sea absorbed that carbon pulse and turned acidic. On the deep sea floor, the benthic Foraminifera, tiny shelled creatures that had survived the end Permian and every mass extinction since, dissolved and died in one of the sharpest deep ocean extinctions in the fossil record. James Zakos and others read the whole event in the rocks as a violent lurch in carbon chemistry, the signature of a planet swallowing more carbon than it could handle. The ocean floor kept the receipt. Recovery took roughly 200,000 years. The PETM was the fastest large carbon release before the industrial era. Peter Brannan, in The Ends of the World, uses it as the closest natural rehearsal we have for what we are doing now. But here is the part that should stop you. Geochemist Richard Zeeby and colleagues calculated the rates, and today we are releasing carbon roughly 10 times faster than the PETM did at its worst. The PETM recovered. It took 200,000 years, and it wiped the carbonate life off the ocean floor to do it. Right now, the air around you is about 420 parts per million carbon dioxide, and the needle is climbing faster than it moved in the worst carbon spike the Earth had seen in 50 million years. So ask the honest question, what does recovery look like when the ingestion rate is 10 times higher?